Let's learn about storage class specifiers in C programming language. When we declare a variable, its default scope, its lifetime, and its initial default value depend on where it is declared. By scope, we mean in what part of the code can we access the variable. Lifetime means in what part of the code does the variable exist. Like after a certain part is executed, it is deleted from the system. And the initial default value is what value it takes if we do not initialize any value to it. So we'll see this with a simple example. Here in this code, y is a local variable. It is local because it lies within the curly braces of the main function. X is a global variable because it is declared outside of any function. So in terms of their scope and lifetime, y is accessible only to the function main. No other function can access it. So that is its scope. And for x, the scope is the entire file. So any function in this file can access the variable x. Y being a local variable has the lifetime of the function call main. And x is a global variable. Therefore, its lifetime is that of the program. When the program terminates, x dies. So this program particularly illustrates the initial values, the default values that these variables take if we do not initialize them to some particular integer. So here the expected values are x should be 0 because it's a global variable, and y can take any garbage value. It can be 0, it can take any number which lies in the memory location which it takes. The reason we use storage class specifiers is to refine the declaration of variables, functions, and parameters. So there are certain things which we can control using storage class specifiers. They are default initial value, then where they are stored, whether our variable will be stored in a register or in a memory location. The linkage, this means that we can declare external variables also, which means that some other file can define the variable which I have declared in my current file. Then the scope and lifetime. So we have 4 different types of storage class specifiers in C: auto, register, static, and extern. In this video, we'll see auto and register. So auto stands for automatic and is the default storage class for local variables. So if we do not declare a local variable with any storage class specifier, then it takes auto by default. So we'll now write a program, auto.c, and we'll play around a little with it to see what we can do with auto and what we cannot. So here I write a simple program declaring a variable number, and I'm not specifying any storage class specifier here, and we print its default value and the address where it is stored to see where it is actually going. So we save it, compile it, and run it. We see that the default value is coming out to be 32,765. Now this is some garbage value because we did not initialize it to anything, and that's what we expect of a local variable. If I declare it as auto int number, it still makes no difference to my program. It shows the same behavior as was without auto. So that kind of confirms that auto is the default behavior of a local variable. Next, we are creating another function called test scope, where we try to access this variable number and see if we can access it here. Again, we save it, compile, and then we see this error here, number undeclared, first use in this function. So if I declare another local variable number inside test scope and then we compile and run it, we see that it works fine. So our takeaways for the auto storage class specifiers are: default initial value is indeterminate or garbage, it can take any value. Where is it stored? Memory. lifetime within a block, so the block where it is defined. In fact, each time a block is entered, storage for auto objects defined in that block is made available. And when the block is exited, the objects are no longer available for use. They are deleted. The scope is block scope. Linkage, there's no linkage associated with auto. So this is the entire summary. Then auto variable in a recursive function. So let's see how it behaves in a recursive function. If a variable is declared with the auto storage class specifier inside a recursive function, memory is allocated for the object at each invocation of the function. So we'll see this with the help of a program. In our auto.c, we call this test scope with the parameter value 2, and here we write a while loop where we are decreasing the value of count with every invocation, and then we call the test scope function from itself. So test scope count, and we print the value of count and the address that this variable number takes. So now when we compile it and run it, we see that it takes two addresses, as the function test scope has been called twice. Now that we have seen the behavior of this class storage specifier auto, let's see where all can we use it. So it can be used before names of variables declared in a block, because it's same as local variables, and it can be used before names of function parameters. But then since it is the default behavior of local variables, mentioning auto is just redundant. It's not even required. Now let's try another thing. In our file auto.c, let's try to declare a global variable with the storage class specifier called auto. So auto int x. Now compile it. We see we get an error. So auto storage class specifier cannot be used with global variables. So that's an important point to remember, and can be used for any tricky questions in your exams or interviews. The next class storage specifier is register. It is exactly like auto, with the only difference being that it requests the compiler to store the object in a register. Now why would we want to do that? The CPU has a certain number of registers, and they are closer to CPU than the memory. So accessing registers is very fast compared to the memory. So if you have some function which is time consuming, like let's say it's a loop. So for a loop, you would want your variables to be such that they can be fetched quickly by the processor. In that case, you would want to declare them as register variables. However, the processor only has a limited number of registers. So it's possible that even when you declare a variable as a register variable, it might not be possible for the compiler to allocate a register for it. So in that case, it will behave exactly as an auto variable behaves. Let's quickly change auto to register in our code and see what extra things do we need to remember for register specifier. So in auto.c, I just changed both the auto keywords with register, and for now I'm commenting out the printfs that use $number because it uses the address of the variable, whereas register does not have an address. Memory locations have addresses. So we'll see how it works. In this case, it has taken the default value 0. That's garbage actually, because it's a local variable. Another possibility is that it actually went to a register which had the value 0. Again, it's garbage for us in either case. Now if I uncomment the printf statement in main function and compile it, I get an error, address of register variable number requested, which is quite obvious. Register does not have an address. Just like we did for auto, we also try to declare a global variable using register. As expected, it is not allowed. So the points we need to remember about register storage class specifier are: it behaves exactly like auto, except that the variable may be stored in a register depending on whether a register is free or not. Also, we need to be careful about these points, that we cannot use pointers to reference objects that have the register storage class specifier, because register does not have an address. So we cannot use the register storage class specifier when declaring objects in global scope. That's same as auto. And a register does not have an address, therefore you cannot apply the address operator to a register variable. So that's it. In the next video, we'll be studying about static and external storage class specifiers.